Hey guys, welcome back to the Dumont RA-102 console television restoration project, better known as the Clifton. Well, we still have a few days to go before the new twist-loc electrolytic capacitors arrive, so I thought I would switch to testing the tubes. Just tested the 3 5U4s in the power supply. They all test fine. I would test the OC3, except Hickok 608 isn't listed in the tube chart. So let's switch to the main chassis. Right now I have one of the 807s installed, and it tests good. Now the 807 that's on the power supply chassis is dead. It's gone to air. Looks like the plate cap broke loose and air got in through that lead. The getter's all used up, so I need to track down at least one 807. The antique radio convention is in 3 weeks, so I expect I can pick one up there, and several of you have offered me some if I need any. I might have some in my stash, I'm really not sure. Now, for those of you unfamiliar with the 807, that is a pre-war type beam power tube with a 5-pin base and the plate cap on top. You don't see many post-war TVs with the old pre-war style base. Although you may be very familiar with this tube because it's basically the same as the 6BG6, which was so commonly used as a horizontal output tube in so many post-war TVs in the 40s anyways. It's the same thing, they just put an octal base on it, and yeah, and that's it. So it's not quite as exotic as you may think, but it is still cool to have them used in a set. So let's pop the other one in and see how it fares. Now these two came out of the main chassis. They're used in a push-pull configuration to power the horizontal output transformer. So I would imagine having tubes that are fairly closely matched would be ideal. These are two different tubes. This one's Raytheon, that one's an RCA. They test close enough, I'm sure that's fine, but it would be nice to get a matched pair. Ooh, well, that doesn't look right. Oh, there we go. The plate cap might not have been on securely or something like that, but yeah, they both test really strongly. Now let's check another one of the larger tubes. This is the 6AS7 dual triode damper tube. Let's see. JX45061. JX45061 and 179. Don't think I ever had the bias on 100 before. Just 179. There we go. Alright, it is lit up. Shorts. There we go. Well, it's two tubes in a row that weren't making very good contact. Makes me think I need to get a new cheater socket on my tube tester. That's one half of it. And about the other half. 21035. 21035. Tube went out again. Lit up again. I think only half of this tube is lighting up. Now, I just happened to be out in the tube stash earlier today, and I stumbled across one out in the garage. So, it's a nice RCA 6AS7G, and actually it's a Jan. Well, it's an RCA made in 1939 for the military, Joint Army Navy. So let's check it out. Something's wonky with this tube. It's a dual triode, but only one half of this tube is lighting up. Alright, both halves are lighting up in this guy. I'm not having to wiggle it around, so yes, I think something's up with this tube. 1952, so it's not an original, and it's GE. Looks like the getter. There was a getter kind of all along the bottom, but it looks very kind of discolored in this area. Anyways, see how this guy tests. It's drawing more current. Both filaments are lit up, so I had to do a line adjust on it. Test very good. What was it? 45061. Alright, the tube tests very good. So we will go with this guy. Well, finished replacing the several paper caps down here and the line filter caps. I used some ceramic caps rated for across the line or from line to ground duty. What else can we do while we wait for the new electrolytics to arrive? Well, there is this oil-filled 10 microfarad 600 volt cap. It's on the 400 volt supply line. It's right after the rectifier, before the relay. So when the relay is not engaged, there's no load on it. So this is the peak output voltage of those rectifiers, so that's why they used a beefy cap. It's not an electrolytic, which means there's a decent chance it's still good. Yes, it's paper and foil, but it's impregnated with oil, and generally those hold up pretty well. So let's give it a test on the old bridge. Got it hooked up here. Let's start out with 100 volt. Alright, that's a good sign. Alright, if the light goes out, it means there's no leakage. If it's flashing, it's a little bit leaky. Go back the other way, it's discharging, so it's holding a charge, minimal leakage current, and then I can pass it back. I'm not used to seeing one flash though when it's discharging. That's a little odd. Well, let's keep going. So there is a 300. I don't think, even if this passes the test, I don't know how comfortable I'd feel using this long term, partly because I'm just not that familiar with them. I'm used to seeing them in transmitters, military kind of stuff from the 40s. Not so much in televisions. Here we go at 500. And yeah, it's probably okay. And the set is fused. Actually, it has a number of interesting safety precautions. Pull out the schematic. I was kind of puzzled by something when I first saw it on here. It's a gas regulator tube, the 0C3 or VR105. Between pins 3 and 7, there's just a line. And if you trace that out, it goes down to the AC line. So there's our AC coming in. So we've got fuse, we have an AC interlock, we've got those 2 pins on that tube, and then it goes to the power switch on the set. So there's a whole lot of things that can interrupt the power going through to the primary then power transformer. So what is this all about? Well, I looked up the tube, and that is an intentional design feature. They have a shorting bus inside of that tube, and the idea is if that tube is not present in the socket, the device won't turn on. They design it intentionally so that you're supposed to incorporate that feature into your power supply design. The thinking being that this is typically used as a voltage reference on a power supply, and if it's missing or failed, they don't want the thing to turn on. So that's why they do that. So if there was, say, a dead short in the power supply, that would burn out. We've got a fuse down here. So, if we left this capacitor in here and it failed, probably one of the safety features would protect the set. Like the fuse is blown in the set right now, currently. Still not sure I'd feel warm and fuzzy about leaving it in, but yeah, all this time I've been talking, I've had 500 volts on it, and the light never flashed once it settled down. So we'll see. I'll probably do once the new electrolytics arrive, which should be tomorrow. But then I'm going on a little vacation, so it's going to be, and then the convention's coming up, so although this is one of the fastest, maybe the fastest recap I've ever done, I don't know how much time I'm going to have in the workshop after those capacitors arrive, but I'm inclined to just pop them in and leave that oil-filled cap for the moment and try powering this setup. But I think long term, we really want to think about replacing that with something. Hey, guess what just arrived? The order I placed with amplified parts. The newly manufactured twist-locs. That's nice. Got a sticker from Amplified Parts. Huh. That is a freaky thing to behold. Boy, these are identical to, let's see, I got one around here somewhere. These are identical to a twist-loc. The aluminum can, the way it's crimped over the phenolic wafer, the lugs, the twist-loc tabs. Yeah, I can see why people use these. It's just trivial now. Just take out the old one, pop this guy in, twist the lugs, wire it up, and we're done. So, if you recall when I went through and was trying to figure out what caps to order, it's helped because 3 of them, or was it 4 of them, are just 4 sections of 10 microfarad each. So, the originals are 475, I got 500, so bam, bam, bam. Those will just drop in and be identical. So there was one that was a dual 40 at 475. I got a quad of 20 at 475, and I'll just wire these in parallel, which actually is more beneficial because you get lower ESR if you parallel the caps up. So that's totally fine. Totally fine. Similar deal with this guy, if I remember rightly. I think I needed a 20, a 20, and a 50, so I'll just put these two 25s in parallel, and so on. So yeah, I was able to get what I needed. And then there were a couple that were, it was a single 40 at 475. I was kind of on the fence because I could have gone with, I don't think they have any twist locks that are just a single cap. And I don't think they did back then either. If you recall, when I was looking at the original caps on one of these, they didn't even use one of the sections because there's not an infinite variety of caps back then or now. You get what you can that's closest and you make do. So instead of getting a dual 40 or a quad 20 and just using part of it, I went with a dual 30-20, and I'll put those in parallel. Remember, the original tolerance on these, I believe, is plus 40%, minus 10%. I've seen some caps that are plus 80%, minus 20%. So you got a pretty wide wiggle room in there to still be in spec with what was originally used. So using a 50 in place of a 40 is absolutely fine. And again, with two of them in parallel, we get lower ESR. So that is fantastic. The only one I messed up on, because I was just looking at the parts list, I took a quick look at the chassis and thought they were all twist locks. 7 of them are twist locks. One is not. In fact, we're looking at it right here. And it's the one I had the most trouble matching, and I wish I had looked at this a little before, because this is not a twist lock. There's one capacitor. It's not a twist lock. It's like they used in radios in the 30s, where it's got a threaded base and they put a big old nut on it. And that is the oddball one. It's 500 microfarad and only 50 volts single section. So I had gotten a dual, a 30 and a 150. I figured parallel them up to get 450, which is pretty close to 500 within spec if you go with that the tolerance range. But I can't use this without cutting slots into this because it's not meant to have a twist lock. Not only that, but this type of cap, I'm pretty sure I can rebuild and reuse the original can. So, oh well. I don't think I can return this. I'll just hang on to it and maybe use it in some other project in the future. And I gotta say, man, yes, they're a little bit expensive. Man, the cost savings, or the time savings, I should say, are tremendous. And whether you're going to install terminal strips and put discrete caps in them, or rebuild them, or whatever you're going to do, there's no question this is the fastest to install. Because they plop in exactly where the originals were, and in most cases the lugs and the symbols and all that are exactly the same, and you just wire it right up exactly it was originally. All the wiring is going to match it what was there originally, so just super easy to blow through it. Now I'm going out of town. Just as these, I was getting a little antsy because these were delayed a little bit in shipping. I'm going out of town tomorrow, so I don't think I'm going to have time to do it. In spite of, yes, this will be quick, I don't think I'm going to have time to do this until I get back from vacation. This is going to be a little bit of a break in this project, but as soon as I get back, I'll pop them in. Which leaves a few things. Well, we don't have the relay, unless I scavenged one from another set, which is not out of the realm of possibilities. I do have some RA-103 chassis, which use the same relay. Or, for the time being, I could do a couple things. One, I could just simulate it and leave this open and let the set warm up and then short it out with an alligator clip or something like that to be a human relay, in other words. But yeah, we can continue on and do stuff. We can finish the recap. We can do a slow power up or a controlled power up regardless of the relay. In fact, because in the radio mode, this relay stays open. So we should be able to get the AM radio working without having to worry about that relay and a whole lot of other stuff. In fact, yes, now that I think about it, because the AM radio only uses the 300 volt portion of this. And hey, something else. So I was talking about, hey, this cable looks to be in pretty good shape, and this carries all the power from the lower chassis to the upper chassis. And it's got a big power transformer, but one thing that was bugging me, there's a lot of tubes on that upper chassis, which means it's going to draw a lot of current for all those tube filaments. And none of these wires seem beefy enough. You'd want like a 10 gauge wire or something like that, or maybe several wires in parallel to carry that much filament current. Then I remembered, wait a minute, there is a big transformer on that upper chassis. What is that for? I'm talking about this guy right next to the 807s. That's a filament transformer. So that big transformer on the power supply chassis is just filament juice for the few tubes that are on it, and it's the B plus supply for the 300 and 400 volt rails. This supplies the filament power for all the tubes on the receiver chassis. So that solves that little mystery. So these are the caps I'm going to replace. Let me grab one of the new ones. So for example, these two guys are 4 sections of 10 microfarad each. And yeah, I mean, not only do they just plop right in, they're exactly the same size. I saw some comments questioning if this would be worth it. Are they going to look the same as the originals and all that? I mean, the can and the lugs and the twists and the size and the shape is exactly the same. They're nice and shiny. But yes, there is one glaring difference. These have glued on labels and these have stamped markings. I'm okay with that. I'm okay with that. If I wanted to, I could take these off and they would just be silver that have no markings on them. I think I'd be more comfortable leaving this on if anybody in the future works on this. If I take this off, they're not going to know exactly what the heck is going on. They won't know if it's the original or if it's been replaced and what the values are and how they match up with the symbols. So I think it's better to leave the label on there. Why didn't they stamp them? I don't know. I mean, they have all this vintage equipment they use and they make them beautifully. Maybe they didn't have the piece of equipment that would stamp the aluminum for the values. But regardless, I'm really looking forward to installing them. See, I can just pop this in here, see how they fit. There we go. I imagine some of you are wondering, hey, how do these caps actually measure up to modern, more conventional caps? Well, here is a Nichicon 10 microfarad 500 volt cap. Here's my LCR meter at 120 hertz. We got just a shade under 10 microfarads and about 5.6 ohms ESR at 120 hertz. Let's check out one of the new guys. Just a bit over 11 microfarads and about 6 ohms ESR on that section. Let's check some other sections to see how consistent they are. Capacitance about the same, slightly higher at 6.2 ohms. Same microfarad, about 5.9, and the last section, 11, and about 6.9. So very similar in performance to a Nichicon